just imagine that our Mother Earth is not tilted. See, here we have the picture. Now in this picture we see that the Earth's axis is perpendicular to the sun's rays. So this is the picture of the Earth that is not tilted. If you remember, we have already discussed about these pressure belts. There exist 4 major pressure belts all over the world. The first one is the equatorial low pressure belt. The next one is the subtropical high pressure belt. It exists both in the north and in the southern hemisphere. Similarly, subpolar low pressure belts and polar high pressure belts exist in both the hemispheres. Now, each of these pressure belts, as you can see from the picture, has a definite extension. Now, while discussing about these pressure belts, we assume that our Earth is not tilted. So, the sun is vertical over the equator. So, do you think the pressure belts would remain stationary at their current location if our Earth becomes tilted? I hope you will be able to answer this question at the end of this video. Now, this is our true Earth. As you can see in the picture, our Earth is tilted at an angle of 23.5 degree. Now, the Earth is tilted at this angle from the perpendicular line to the orbital plane. This is the orbital plane, and a perpendicular is drawn at this orbital plane, and the angle between this perpendicular and the Earth's axis is 23.5 degree. So we can see that our Earth is inclined at an angle of 23.5 degree. Now, due to tilt of this axis, it may happen that the northern hemisphere is inclined towards the sun, or it may also happen that the southern hemisphere is tilted towards the sun. Now, due to this inclination, different latitudes present on the Earth gets heated differently at different points of the year. For instance, in this picture, we can see that the North Pole and most of the northern hemisphere get more heated compared to the southern hemisphere. Whereas in this case, we can see that most of the southern hemisphere gets more heated compared to the northern hemisphere. So here we can see that due to inclination of the Earth's axis, different latitude gets heated differently. As a result, pressure and temperature conditions also vary. Now let us see how these positions of the Earth occur. We know our Earth revolves around the sun in 365 days. Now, during this revolution, the Earth's position with respect to sun changes. So, these are the different positions of the Earth. Now, in position A, we can see that the northern hemisphere is tilted towards the sun. Again, in position C, we can see that the southern hemisphere is tilted towards the sun. Now, in positions B and D, a tilted Earth faces the sun. So, we will now see the conditions of the Earth in these different positions. In position A, as we discussed, the northern hemisphere is tilted towards the sun. As a result, the sun is vertical over the Tropic of Cancer. So here we can see that maximum part of northern hemisphere receives sun rays. So it is summer in northern hemisphere, whereas in southern hemisphere major part of it receives less sun rays. So it is winter in southern hemisphere. Now also the duration of day is maximum in northern hemisphere, while night prevails for shorter duration. While in southern hemisphere nights are longer while days are shorter. Now this moment of the year is known as summer solstice. Now the particular day on which this occurs, or the particular day on which the sun is overhead the Tropic of Cancer, is 21st of June. So this phenomena or this moment of the year is also known as June solstice. Now here we have named June or summer solstice with respect to northern hemisphere. That is, northern hemisphere experiences summer on June. So this moment of the year is known as June solstice and summer solstice. Also a point to be noted is that on this day the duration of day is maximum in northern hemisphere. Now the conditions gets reversed on 22nd December. On 22nd December the sun is vertical over Tropic of Capricorn. As a result, the days are longer in southern hemisphere while the nights are shorter. Due to this, it is summer in southern hemisphere. Now let us see what happens in northern hemisphere. In northern hemisphere, as we can see, days are shorter while the nights are longer, and also a major part of northern hemisphere receives less sun rays. So it is winter in northern hemisphere. Now this moment of the year is known as winter solstice, and since this particular event takes place on 22nd December, it is also known as December solstice. And here also winter or December solstice is named taken into consideration the northern hemisphere, which experiences winter in the month of December. Now I just mentioned that these moments of the year are known as solstice, where sol means sun and stills means stop or stand still. Now why these phenomena are known as solstice? This is because on 21st June the sun is vertical over Tropic of Cancer. Now the sun does not shift further northwards beyond this latitude. And again on 22nd December the sun is vertical over Tropic of Capricorn. And also the sun does not shift further southwards beyond this latitude. So the position of the sun or the respective shift of the sun comes to a standstill. As a result, these two moments of the year are known as solstice. Now before we proceed with our lesson, let us try to answer this question. On which of the following days sun is overhead the Tropic of Capricorn? Is it on 21st June, 22nd December, 21st December or 22nd June? Well, the correct answer is 22nd December. On 22nd of December, the sun is overhead the Tropic of Capricorn and the world experiences winter solstice. Now, we have already discussed about the conditions of the earth in position A and in position C. In position A, we experience summer solstice because the sun is vertical over Tropic of Cancer. Whereas in position C, the sun is vertical over Tropic of Capricorn and we experience winter solstice. We shall now discuss the conditions of the earth in position B and in position D, where a tilted earth faces the sun. We will first discuss what happens at position B. At position B, as we just discussed, a tilted earth faces the sun. So, the sun is vertical over the equator. And due to this, the duration of days and night are equal all over the world. So, this moment of the year is known as equinox. Now, equinox is a combination of two words where equi means equal and nox means night, or simply equal days and night. Now, at position A, we have already discussed that northern hemisphere experiences summer, while at position C, northern hemisphere experiences winter. So, as the earth moves from position A to position C, there is a transition from summer to winter. So, we can say that northern hemisphere at position B experiences autumn, which is a transition period from summer to winter, while in southern hemisphere the conditions are reversed. At position A, southern hemisphere experiences winter, whereas at position C, southern hemisphere experiences summer. So, while the earth moves from position A to position C, there is a transition from winter to summer. So, at position B, southern hemisphere experiences spring. Now, since we always consider northern hemisphere while naming these phenomena, so this phenomena is also known as autumn equinox. Now, autumn equinox occurs on a particular day, that is on 23rd of September. And on this day, the sun, as we just discussed, is vertical over the equator. Now, it is also known as equinox because the duration of day and night are equal on this day. Now, the same conditions prevails at position D. At position D, the sun is vertical over the equator. Now, it is springtime in northern hemisphere because here at position C, northern hemisphere experiences winter, while here at position A, northern hemisphere experiences summer. So, as the earth moves from position C to position A, there is a transition from winter to summer. So, the northern hemisphere experiences spring. Conversely, the southern hemisphere experiences autumn because at position C, southern hemisphere experiences summer, whereas at position A, southern hemisphere experiences winter. So, as the earth moves from position C to position A, there is a transition from summer to winter in southern hemisphere. As a result, at position D, southern hemisphere experiences autumn. Now, at position D, as we just discussed, the sun is overhead the equator. And the particular day on which this event takes place is on 21st of March. So this day, that is 21st of March, is also known as spring equinox. Now it is called equinox because here the duration of days and nights are equal. So these are the different positions of the earth with respect to sun. As the earth revolves around the sun, the earth faces these different positions. Now, in which of these positions do you think the shifting of pressure belts will occur? Well, I'll help you to answer this. At position A, as we just discussed, the sun is vertical over the Tropic of Cancer. At position C, the sun is vertical over Tropic of Capricorn. At positions D and B, the sun is vertical over the equator. Now, if you remember, while discussing about the pressure belts, we assume that the sun is vertical over the equator. So, the position of pressure belts will not shift during the equinoxes, that is at position D and B, while the pressure belts will shift if the sun is vertical over Capricorn or Cancer, that is if there is summer solstice or winter solstice. Now let us see how the pressure belts shift. Now this is the original position of the pressure belts. At this position, the sun is vertical over the equator. Now this is the case of summer solstice, where the sun is vertical over Tropic of Cancer. Now, since the sun is vertical over Tropic of Cancer, so this latitude receives maximum sun's heat compared to the other latitudes. As a result, this latitude, that is Tropic of Cancer, gets heated up more. So during summer, the pressure belts shift 5 degrees northwards from their original position. See, each of the pressure belts have shifted 5 degrees northwards, and this happens during summer. Let us see what happens during winter. During winter, the conditions gets reversed. The sun is vertical over Tropic of Capricorn. So this particular latitude gets heated up intensely. So this particular latitude receives maximum rays of the sun compared to the other latitudes. As a result, the temperature and pressure conditions change. So during winter, the pressure belts shift 5 degrees southwards compared to their original position. See, in each case, the pressure belts shift 5 degrees southwards, and this happens during winter. Now, if you remember, I asked a question at the beginning of this video. I asked you that if the pressure belts would remain static or their position will change if the earth is tilted. So here we see that the pressure belts would not remain stationary, rather their positions will shift on account of Earth's inclination and revolution. And here we see that the position of pressure belts shifts seasonally. It shifts northward during summer, while the pressure belts shift southwards during winter. We will now discuss about the impact of shift in pressure belts. The effect of shift in pressure belts is that it causes seasonal changes in climatic conditions, especially in the regions 30° to 40° north of the equator and 30° to 40° south of the equator. Now, why especially in this region? This is because during summer, the sun is vertical over Tropic of Cancer. So, this particular region experiences warmer summer. Whereas at this situation, it is winter in southern hemisphere. So, this particular region experiences cooler winter because the sun is far away from this particular latitude, that is from Tropic of Capricorn at this point of the year. Now, during winter, the conditions gets reversed. The respective position of the sun gradually shifts southwards, and the sun is vertical over Tropic of Capricorn on winter solstice. Now, at this point, the southern hemisphere experiences summer, while the Tropic of Capricorn is far away from the sun. So, it experiences cooler winter. So, here we see that as the vertical position of the sun changes, so there is a high variation in summer and winter conditions, especially in this region. So, due to shift of pressure belts, this particular region in northern and southern hemisphere experiences Mediterranean, so this particular region experiences Mediterranean type of climate, that is high variation in summer and winter conditions. So, this is the effect of shift in pressure belts. So, in today's video, we discuss about the shift of pressure belts. We discussed that the shift of pressure belts takes place due to Earth's inclination and due to revolution of the Earth around the sun. We also discussed about summer solstice, winter solstice, and both the equinoxes. And then we discussed that the pressure belts shift northwards during summer and they shift southwards during winter. And finally, we discuss about the impact of pressure belts. In our next video, we will discuss about winds and planetary winds. Don't forget to subscribe to our channel and hit the bell icon. You can also register for free at DeltaStep.com or download the DeltaStep app to learn one-to-one with our amazing teachers or to get access to our 5,000 amazing videos as per your school syllabus. Master each topic with our adaptive practice technology. Get million-plus questions with step-by-step solutions and unlimited mock tests. Get all your doubt resolved instantly. Learn via games and win amazing prizes like PlayStations and iPads. So at DeltaStep, learning is not just fun and easy, but it's rewarding too. So register for free now.